think I got it for saying that a lot, but I think this time I got it. X min max if x min max test. What is that? What is that? Please, please. Process endstop x min max x min max. If x is min max, x is min max. I would need to define a max endstop then, but that would fuck everything up though. Damn it. Damn it, damn it, damn it. Okay, it's back on. Front face. Please, 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 please work. So that's not even cool, right? So maybe I got it all wrong. I probably got it all wrong. That wouldn't surprise me. Let's connect the printer. Printer T1 send T1. Okay. Oh, at least I'm happy for that, even if it's not much and it just fucking crashed front face. But this works. Let's go. Perfect. Nice. Uploading. Front face. My man. Disconnect. Connect. T1 send T1. Printer is not online. Well, it should be now. Yes, it works. Let's go. I'm gonna short xmin and we'll see what it does. Hold up. Stop. Let's go. That worked perfectly. Alexa, fucking Hi everyone, so yeah, I didn't post any videos in a while, and that's because I just started university, and that's actually quite a bit of work. I'm gonna continue doing videos and working on this project, but the frequency will be lower. And because of that, I've decided that instead of posting new videos every time I did a big jump or a lot of progress, inside I would just do a video like when I have about 24 hours in front of me where I don't have a lot of work or no courses have been registered yet, and I'm pretty much free and I want to work on that project. I would simply work during that basically period of time, and I would at the end present a video about what I did, and this is basically what I'm doing now. So for the people that have watched my previous videos, we are currently, so I've been doing the idler homing. I've been working on that for actually quite a bit, but it has been much harder than I initially planned. So let me show you. So I was initially planning on using the experimental support for up to 6 non-extruder axes from der andere 1, but that turned out that it was not possible to do that for quite a few reasons. So first, on this library, it's like too old. The version of Marlin is not the most recent one, and since I want to possibly have this in the, let's say, official release of Marlin, I need to be working on at least the most recent version of Marlin, otherwise it won't be possible. And because of that, I was like, okay, then I will just transfer his work to the latest version of Marlin and maybe fix the stuff that doesn't work anymore. And well, while in theory that should work actually quite well, in practice it's much harder than that. So the main reason being that the actual structure of Marlin changed a lot between the time this little upgrade, or so this code modification was posted and the current version of Marlin, and there was a significant change. That means that basically everything that written in here either change place in the program or is simply totally different. And because of that, I spent about 2, 3, 4 weeks working like for quite a bit of time on that specifically, and I didn't get any results. So now at the point where I'm at, theoretically the code should work, but I still get a lot of errors, and even when the errors are fixed, just nothing happens. So I have an like indefinite amount of time debugging in front of me, and I don't feel like I have enough time and patience to go through all of that. So I'm gonna change, let's say, change my plan for the development of this. So at that point, I have two options. The first one is, well, use an older version of Marlin, and simply take this code, modify the project to fit with my board, and start from there. The second option would be to actually develop the homing sequence myself, and not trying to stick to the Marlin, let's say, method and macros. And that means that this would be like starting from scratch. So yes, it would be a bit of work, but it should work perfectly fine, independent of which Marlin version you're using. And that's why I feel like this would be a good option. So that's what I'm going to do right now, and we're going to head right into it. And right now I have downloaded the latest version of Marlin, because I was using a like 2-month-old version of Marlin when I was starting development. A new one came out, so because of that I've just downloaded a new one, because the one where I've already done all my modifications is a bit outdated. Not that 2 months is nothing, but if I want to release it, it's actually quite a bit. But it's mainly because I just totally like screwed the code, and I have added so many things I cannot revert back to its original state without breaking more stuff. So I'm going to start from scratch to have, let's say, a clean start. And right now what I'm going to do is configure everything, and check that everything works. And once that's done, I will start working on creating that homing sequence. So I'll take you along with that. I will simply show you the most interesting part of it. Let's go. So the first thing that I'm gonna do is go inside Marlin and take a look more specifically at the homing sequence and how the homing works, so that to see I have the possibility of doing something similar to what I did with the extruders, which is use, let's say, the SOP functions of those homing sequences in order to go around the limitations of having 3-axis. So once I have like uploaded and like put my new code inside of this for the multi-material upgrade, I will show you exactly what I'm talking about. But I mean, I'm gonna see if I can just use commands that already exist, but that are at a lower level, so that I can just put inside a command which axis I want to home, or which axis I want to move towards the homing switch, and to see if I can do everything without going too far away of the actual way Marlin is built. Because if I use totally different methods of doing this, and if I, let's say, go around and just not take care of the parser, and like I still need to stick quite a bit to how Marlin is coded in order to make this work with enough performance, and without causing too many problems with the actual code. Because if I just try to squish in my commands in between other Marlin commands without caring about like everything that's going on and happening inside the printer, this will definitely result in errors and let's say an unreliable printer. So right now I'm going to configure Marlin, and add the new little bits of code. Okay, so now I'm doing the configuration. Basically what I'm doing is taking the old settings I had that were working in my old project and simply copy pasting them inside the new fresh Marline. On the right you have the old one. As you can see in features I already have the MMU configured, and on the left one is the fresh new environment. Okay, so the actual build is finished, everything is working, the configuration is good. I just have one last little thing to do in terms of setup is I'm not going to work on the tool printer, I'm still going to use some kind of testing setup, but right now the actual display of the printer is on the other printer. Okay, so story time. This is my original SKR Pro board that I had, and it had quite a few problems actually. One of them being that the E2 and Y pin did not have any direction control. So that was some kind of build defect. I don't know where or why. But because of that, I couldn't use it. So I asked. I actually ordered a new one because I needed to work on it. I received a new one and it was working perfectly. And I then asked Big Tree Tech if I could get a refund. And I actually got instead of a refund, they sent me another board. And well, if they had sent me exactly the same board, I would have had 3 of them with one non-functional. And honestly, I don't need a second functional SKR Pro. So instead of that, I went for the Big Tree Tech SKR Mini 3. So that's actually a cool upgrade that I got for basically not free, but yeah, they were kind enough to send me a different board than what I had actually ordered initially. So I got that, and now I have this board, which is not functional for like a 3D printer, but that should be perfectly fine when we're just trying to home a single axis. So what I'm going to do right now is set it up with the PC power supply that I had, that I showed you in one of my previous videos, connect it to the MMU2, and we'll start coding from there. But since I don't have any screen connected, I'm going to have to use a serial interface that's connected to my computer, and that's what I'm going to try to get right now working. So let's go. So the actual software that I'm going to use is Pronterface, and I'm going to download and install it right now. Okay, so we're going to install Pronterface, and I'm going to connect it to well, my computer using the cable that I'm gonna have to get. Okay, so now I've successfully connected the board to the actual Pronterface. And this is going to give me quite a lot of possibilities. So because this makes the development a lot easier, so I can run Gcode commands directly from my computer, and I have everything on hand. So even if it's not full like 3D printer, it's going to be enough for me to test my result. So let's say that around G28, which is the homing sequence, you can see that it sends G28 and then it analyzes and gets the printer's answers. And here it's normally going to say that calling error because I don't have any motor, nor do I have any switches connected to both the end stops and the and any motors, so it shouldn't work normally. Let's see. So it worked at first, but right now it's not working. Maybe, let's see, let's reset it. Do we get any answer from the printer? Oh no, that's because printer hardtut kill was cold. That means I need to reset the printer, and now you see a lot of error messages. I'm gonna reconnect, then it's connecting. Here it's now online. I will send G28, and now you can see that the printer will actually send a composite processing, and then it will send. Well, that didn't work because I don't have any end stops, and it will kill the printer. So I need to reset it for it to be online right now. That's why I will stop sending G28, and now we can start developing stuff and test it on our test platform. So for now, it's only the board because I'm going to be mainly using serial communication to test my code. But once I'm far enough, I will actually plug in a few motors and a few switches, and I will also connect the power. So in order to get power, I'm gonna use, let's say, a little cheat method. So I'm not gonna use the 3 printer power supply, which would be, ideal, but I'm gonna use this and this. So this is an old pre-built power supply, which is pretty crap and only about 200 watts, but that should be plenty for 3 printers. So I'm going to connect that up to the motor power and the actual board power, so we can actually control some motors, because USB power won't be enough to control those stepper motors because they require 12 volts and USB is only 5. So now I'm going to get into the actual coding, and we'll see where that goes. Compilation to finish, and once that's done, I will actually open the and put the new firmware onto the board. Okay, so now that we have that, I will go into BigTrace Pro, reveal File Explorer, and then our File Explorer. Where is it? Yeah, right here. Okay, BigTrace Pro. Okay, so now that I have everything working, my previous code is working. I'm gonna go in depth on the actual homing of the axis. So where can I find that? So that would be inside G code, calibrate, and G28, because G28 is the function, the G code function that basically home all the axes. And that's also what I send using prompt phrase right before that. And this command basically includes the homing of the Z, the Y, the X. So that will basically, if I follow exactly what it does, that will bring me to actually likely how it works, and I can go based off of that. So yeah, I will just take a look at it. I've already kind of worked on that before when I was trying to create the new idler. So I already know the basics of that G28 and of the homing sequence. So basically I know that what I'm going to be looking at mostly is the home function that is inside of there. So basically how it works is you have a small condition which is need X or home X, home Y, and that kind of stuff. And if they are triggered, they will home the specific axis using this function, home axis. And this function brings us to the motion.cpp file. And in here, that's where I think that I will find the function that I could use or modify in order to home the axis that is not yet defined, which is the y-axis, and that is the idler. Okay, so I've just realized something that I may do. At that point, I'm not sure. So this is the main function that we're going to modify and that we need to understand well or duplicate in order to work with the idler homing. So this function basically has a few inputs, which is axis, and then you have the length and then the home direction. So nothing special. So yeah, it works basically with the few inputs, so the axis, the distance, and the feed rate. And in our case, so you can see that at the previous, like at the higher level, so which was home axis, you have it takes as an input the axis enum axis, which in here calls either based on the number, it's either going to be 0, 1, 2, 3, 4, etc. And each number corresponds to a specific axis. And in our case, you can see that if because our idler is going to be connected to an extruder axis, we're going to have some problems because those are they don't really have a number attached to them. So you have E0 axis, which is 3, and then based on the active extruder, it will switch between E0, E1, E2, and the other extruders. So that means that one of the possibilities that we could have would be to add an axis inside that axis enum, and then go based off of that. But that would still be quite a bit of work because we would have a lot of things to define. So for now, I'm going to go deeper inside the homing move to see if I can find something easier, but that may be something that I do in the future. Okay, so at that point, if I get everything right, we have the planar. Okay, so here we're in like the second subfunction of the homing, and that's where, let's say, the magic happens. So you have here target axis, so which would be in our case the idler, gets the position 0, so it's reset. Then you start moving the actual axis. You decide to do a move at a certain speed with the relative distance towards the end stop, which would be the printer like max width, because that's the maximum like distance that it could do before hitting the axis. So it starts doing that move, and from that point on, what I get is that the end stop, or at least some function inside that file, checks for an end stop hit, and once it hits, it sets that position as being the known position once the end stop is hit, and it does a second homing move, which is much smaller and also slower. So that's, let's say, when you see your printer homing, it clicks the switch, it goes back a little, and it goes slowly to click it slower and have more precision. So that's what I get from it, and we're gonna try if we can see if we can like do this ourselves. And yeah, that's it. Okay, and here you can observe literally exactly what happened when I sent G28. So let me go back to Pronoface. So here you can see that I sent G28. It printed processing, and then printer cold, kill was cold. And here we can see that's exactly what's happening. So, okay, we were inside motion, right? Okay, so you have planar buffer segment. So that means that it asks the planar, which is, okay, let's say it takes care of all the movement. So it says to the planar, to the axis, to go towards, to make a move from the side of from the position of the idler motor or anything, do a move of the length of the axis towards the end stop, so that even if it's at the like opposite side, it will still touch the end stop. And during that move, the end stop continuously monitors if it has hit it, and once it hits it, it like kind of stops the move. And here, what you can see is that it sends the command to move, then it sends end stop validate homing move. And at that point, if I go to that function, it's basically if the trigger state returns that it hasn't been triggered, so if the last move failed to trigger an end stop, then it calls the kill function. So kill homing failed, and that's exactly what you got in here. I sent G28, so we didn't have any motors and we don't have any switch. So when the homing move is called, the switch don't change state. So that means that the move failed, and then it kills the printer. In the serial print, we received that the printer has been killed. So from that, I can tell that actually I just kind of noted that because I'm doing it my way right now. I'm working on it like by myself, and I'm not using what he had done previously, so the guy that added support. So I feel like I could add support properly, like very easily right now, but that's probably also because I haven't modified anything yet. But right now I'm feeling pretty confident that I could actually do something really clean that would be accepted like in the official release in terms of controlling the idler and homing the idler. So let's get right into that. And the first thing that I will do is check for the end stop code. So inside the end stop code, there must be something that is called that calls the end stop to continue to start monitoring for the printer to hit that that's the end stop, so the specific end stop. So now I'm going to go back to G28 to start from the really beginning and see if at any point it calls for an end stop monitoring. Okay, so here end stop enable. That could be it. I'm gonna check what that does. Enable. It's actually nothing much going on here. There's probably not all of it. So I'm gonna continue checking inside the program for like any end stop monitoring for the homing. Okay, I got it now. So let's check that out. So when the end stop is hit and it updates that it has been hit, the actual end stop CPP file calls the planner CPP file and calls end stop triggered. And what end stop triggered does is it literally stops the printer. So that means that it shouldn't be really hard to modify our current little code here to work with a new axis, the new axis being the y-axis. But I really need to process step by step in order to not fuck up the code and not break anything. So that's what I'm going to get into. Right now I'm going to try to understand better, and let's make a plan of action. And I'm going to try to do the y-axis home or move. So for that test, I'm going to connect the idler to the extruder 1 port, which I highly believe is functional. I will connect it to the X port, which I know is functional. So this way, I'm sure that it will work properly. Now I have to know if I want the homing of the idler to happen during G28, or if I want the homing of the idler to be part of my code. I feel like the easiest solution would be to make it part of my code, actually. because making it part of G28 would mean that if someone calls, like, I know, a different command, and I mean, I don't want to tie my not super functional homing to G28, which is really important for the printer to work. So I feel like for now, the best solution would be to reproduce the homing of an axis inside my CPP file. And no, this is the MMU2. I want the MPMMU right here. So in that, let's see. Should we home the idler when the printer is turned on, or should we home it when the tool change function is called? Let's see. Well, we could do because a tool change is not something that's going to happen like super often. At least like on the scale of a printer, a tool change may happen every 10 seconds in some rather complicated print, but it's not like it's not super, it doesn't happen very often. So what we could do is simply add an if statement and have an is home set. So we would need to create a Boolean variable, which would be basically the homing state of the idler. And let's say that every time we initiate a tool change, it checks if the printer is homed, and if it's not homed, it does the homing sequence, and then it does the filament change. Yeah, that would be a good plan of doing it. So I'm gonna start right now. And we want that value to be false initially, so we don't want the actual when you start the printer, we have no clue where the idler is, so that's the point. Now we should add right here if wait false, then if the idler is not homed, then you would do the homing move, and if the homing is unsuccessful, well, the printer okay, and once it's homed, we can say that the idler homed equals true. Okay, so now what I have to work on would be the homing of the idler. So that's what I'm gonna get right into. So what I'm gonna do right now is I'm gonna try to go as low as possible inside those functions to get, let's say, the raw code of Marlin, and I don't need all those securities like if it can home or if it cannot home. I will add them later, of course, but right now I'm just trying to make this work. So I'm going to try to skip a lot of the securities that are added. So I'm going to check if this function has necessary components, and if it doesn't, I will go to the, let's say, lower sum function. Okay, so in here we have two things that happen. Basically, it calls two homing moves, and wait, it kills two homing moves. I have to go to the initial function to know where it starts and where it ends. So home axis starts at 1534, and it ends at 1834. Okay, so in here, basically what happens? So we have literally two main steps and a lot of few steps that you can reproduce later in our code. So let's go back to home axis. So first handles if like it can home security so that you don't literally break your printer, but we don't care about that. We're simply at a prototyping state right now. It handles SCAR printer. We don't care about SCAR printers right now. Eco pair debugging, so basically serial communication to have them either debugging information. We may add that, but on more specific cases when it doesn't work for us. So the home there will be like a constant for our idler. It won't change like for this is for x-axis for multiple extruder setups. But we don't care about that in our case. Then for the z-axis, so if there's a probe, in our case we don't have any probe, we don't have any extra end stops. And then what it does is calls the first homing move. And once the first homing move is called, it basically decides and set up the bump for the axis. So the bump being the amount that it needs to go back before hitting the end stop once again to get like a more accurate position. In our case, I feel like the first step that we would need to do would be simply to have a homing. So basically the idler go click on the end stop and just not move. We don't need to have a bump. We don't need that much precision right now. So at that point, I just want to get a successful homing, even if we don't have a bump. A bump would be quite easy to add later on. And the bump is basically everything that happens from here to the line 1631. Then it handles extra end stops as well. And then it handles different types of stepper motors, so TMC stepper motors, then SCAR printers, then Delta printers. And then it sets the axis position as the home position. In our case, I want to say that we are not going to do that because I'm going as close to Merlin as I want, but I'm just kind of going on the side and not sticking really to the way they code because I don't want to add a fully functional axis. And if I decide to do that, that means I have like literally 7,000 like lines to replace or change. And I tried to do that in the last 1 month, and I can tell you it didn't go well. So it literally hours and hours of work out of like in the trash because it's not. Well, it is possible, but I'm just kind of like too lazy, and I don't have the will right now to work on that. And I just want to make it work, and this should be plenty because we just need to home it. We don't need any like complicated acceleration patterns. We don't need some heavy monitoring of the position. We just need it to home and to move by a certain amount of steps. That's all we need. So I'm gonna try to stick to bare minimum for now, and yeah, we may work on that later. And I mean, once I have finished the project and it's open source, someone could go and handle the task of adding a super clean idle axis. And then it handles probe, delta printer once again, then the retraction, and that's it. Okay, I'm really not sure, but I'm gonna try something. I feel like what I could just do is stick with the initial thing I had found, which would be the planner buffer line, which gives me the ability to specify the extruder I want. And when driving, well, on purpose, the idler into the end stop, it should get triggered. But now I have to define the Y end stop. So that would help me a lot because I don't have to do all the movement to define new axis for the movement. But I still need to define the Y, uh, the I, sorry, end stop. So let's see. So that would be, let's say, and reset the position afterwards. No, because you have an extruder position actually. So I could maybe use that. Let's see. So if I do the homing on purpose, and then I check if the it has been homed successfully. Okay, so let's see. G28 home axis. It was where was it? Do homing move inside the do homing move. It should check planner buffer segment and stops validate homing move. So now, okay, in MMU. Okay, so it drives the idler straight into the end stop. Okay, we check if the homing move has been done. Okay, so I need to include the end stop. Where would that be? Next motion? Yeah, most likely. Let's go. It was right there. So now that I've included end stop, I can do validate homing move. What that does is it checks if the end stop has been triggered, and if end stop has been triggered, it says okay, you can go ahead. If not, it just kills the printer. So that would mean that my kill case would be done. After that, once that command has been successfully done, we can literally say that the homing has been successful. So the extruder position would be set to 0, but the problem is that the extruder position is not independent of the extruder number. So that means that there's an extruder position for every single extruder. And that gives us a problem and makes it more complicated. But what we could do would be to create another extruder position. So that would be the idler position that we will handle locally. So let's say, okay, so we create a float, which is called float, which is called the idler position. Which is unknown at the beginning. So we'll stick to that. But once the end stop has validated the homing move, that means that we got it. That means that we have the idler position. Well, position. That's not right. Okay, so idler position equals to 0, and the homing is done. So now the idler homing is true, and we can do every single idler movement based on that idler position. But we just need to be sure to keep the stepper in the lock position, so the stepper enabled. We need to have the power to the stepper all the time, because I'm probably sure that there's a function just to save power to shut down your extruder when it's not being used. And since we're only going to use the extruder connected to the idler when we want to change filament, that means that it will run out of, it won't be powered on, so it may lose its position very easily. It's like you see when your printer is not powered on or has not turned on any move yet, you can really easily move all the axes, the Y, the X, but when it's actually powered on or has been printing something or you have done a move, they are locked in place. And I want to have that behavior to lock it in place when I'm not using it on the idler side of things. So I may need to work on that. So now I just need to be sure. So this would be the extruder. I'm gonna be using the extruder number 1, E1 for the idler, E0 being, let's say, the default option for the extruder, for the actual extruder. So E1 would be the extruder, and I need to reset the extruder position, otherwise it will like kill the rest of the code. And that's because the buffer line skips a lot of the position update steps, so I still need to update those. So that would say this updates the extruder so that it still works normally. This validates if the homing has been done. If the homing has been done, we can say that the idle position is now 0. But I have a problem, because if we use that, then the position won't be plus 100. It will be like dependent on the time where the endstop was hit. So I'll do a super long move to check to know well like that the endstop and the homing is working. And I have idler position 0. Okay, I need to do some set testing at that point. So let's check. Would that run? And I could use a serial print, or the equivalent of serial print, for the printer to check the idle position value, or to know that the idle position has been updated. Okay, that will do that. So I can check in my debugging if it has worked correctly. Oh, well, that would be fine. That would be perfectly, actually. Okay, so now I'm actually building the final, not final, the test. Oh well, let's see all those error messages. So what I was saying, I am currently compiling and doing that little homing sequence just so that I can test if it works. So let's read that warning. Boolean is deprecated. Well, what am I supposed to do about this? Is there... Wait. For now, it's just a warning. I mean, deprecated just means that it's not like it will maybe removed in the later version. I doubt that the boolean variable will be removed. But anyways, they tell me that it's just a warning. That should still work. I'm gonna compile that. I'm gonna send it. Okay, so I've already compiled it. I'm gonna plug in the SD card. Okay, the SD card is in. PIO, build a bit2tech, rebuild File Explorer, and then the firmware.bin file on my SD card. Okay, now we have the new firmware. I can upload it to the board. What I will do now is I will get my phone and connect a Droid cam so I can show you everything that's happening at the same time as me, so I will have two cams input. I'll be back in a sec. Okay, so I just added my phone, which is running Droid cam right now. Well, not the iOS version of it, because well, the broken phone story, right? I initially had an Android and now I'm stuck on an iPhone. So I'm gonna add a video capture device, Droid cam, and it's going to be the Droid cam source 3, which you can see right now on screen. Okay, I will place it somewhere out of the way, because yeah, my screen is still pretty important at that point. I may do a few modifications. We're gonna keep it that size for now. So sorry for the small watermark on the bottom right with Droid Cam OS. I cannot change that without paying, and for now I don't have enough money to buy multiple cameras. Okay, so I'm gonna try to show you what I'm working with here. Let's see. Yeah, there's kind of a delay between the and maybe some artifact as well, so sorry for that. Okay, I'm gonna lock it in place right here, and we should be good. That has nothing to do here. Let's start. Okay, so right here we have the power supply, which is the 200 watt power supply, which has 12 volt rails. Right here, I'm gonna get a screwdriver. I'm gonna connect it to the board. I'm gonna switch to actual power supply power. So this input and not USB power with this little pin right here that I'm gonna move one. You probably can't see it because it's not high quality enough. And then I'm gonna get a dummy, let's say idler motor. And I'm gonna get an endstop as well to see if it works. So I'll be back in a sec. Okay, so I'm back. I'm going to connect first the power cables. So because I'm going to work on that and I don't want to kill it, I'm gonna unplug it first. The yellow wires are the 12 volts and the black wires are ground, as you would expect. I'm gonna connect the power here and right here. Okay, so now that those two are connected, I'm going to take that motor right here, separate motor, and I'm going to connect it to the extruder. Which one were we using? Okay, let's see on the code. Can you see that? I'm gonna make the window smaller. Right here you can see that in the homing we're using extruder 1, so that's what I'm going to be using right now. So let's see, connect to extruder 1. This is extruder 0, this is extruder 1. I believe the ground should be in this direction, but I will change it if it doesn't work. So let's see. Go to board power, plug it back into the computer. So now you can see that the board is not powering on. That's because we switched to board power, and this means that until this is not plugged in and turned on, it will stay off. So I'm going to connect the actual power supply right now, and I did connect it, but you can still see that it's not turning on, and that's because computer power supply don't turn on when they're plugged in. You need to have a specific switch, and that actual switch and trigger is caused by the computer, which basically shorts two wire or well, on the motherboard, which shorts 2 wires of the power supply, and this causes the power supply to turn on. And those 2 wires are the green and the black wires in my case, but don't take me on that because I have like a really weird ass power supply from pre-built, so it's not going to be the same on your power supply most likely. Well, even if the color codes are still the same, because as you can see it's on my 4-pin when it should be on the 24-pin. So I'm gonna get a jumper wire and I'm gonna short those 2 cables in order to get power right now. Okay, so I got my little jumper wire connected from the green right here to the black right here, and you can see it turned off for a sec. I'm gonna try to find something to secure it. So you can see the 2 wires are shorted right now on there, and you can see that the board actually turned on. Okay, so focus is good right now. Let's see. Now, if on my computer, I'm gonna reduce. Wait, hold up. That's not what I'm planning on using. I'm going to reduce that window, and let's focus it on simply the motor, which is what is interesting for us right now, not anything else. And now we have to send a tool change function in order to run our little homing sequence right here. I just don't want that homing sequence to do any moves. Oh, well, they're all defined to do some move. So I'll just uncomment this and every single line that is a move during the tool change. I still want serial feedback though, so let me get that back. Okay, and now we'll compile that. Control Shift build for the B3 Tech SKR Pro, and yeah, I know that this won't work because the actual I believe that the endstop let's say breaking point will depend on which axis is moving, and since I haven't defined the e-axis as being a potentially endstop triggering thing, it won't work because like let's say I haven't defined the extruder endstop yet, so this shouldn't work. But it's just to test. Like if I just want to try, let's say if I short the X, so if let's say the X endstop is triggered, will it stop it or not? Well, I could find that out in the code, but it would be quite a long task, and it's just easier to test it. Now, how will I let's say simulate having endstops? Well, the easiest answer would be hell, just plug in an endstop. But because I am lazy, I'm just gonna use that little secret trick that some PC builder may know, which is simply stick a screwdriver in that and short the 2 pins. So let's say small demonstration, I want to short the X pin, I will stick it right here, and you should see the X LED turning off right below my hand. You see it right now. There's a bit of a delay, but when I touch it with my screwdriver, it shorts the 2 cables and acts as an end stop. For the firmware, it's the exact same thing. What is that switch? That switch is literally like what I'm doing right now. So I will run the command. No, first I need to rebuild that. I did rebuild it. I need to upload the new firmware to the board. So let me get that right now. Rebuilding File Explorer, B3 SKR Pro, firmware.bin. I will copy that. I will go into the removed F, delete that old or new bin. I don't remember. And then paste it. So now I have my new build file. I will get it from the SD card, and let's see. Let's plug in the SD card. I'm doing it on the side right there. You can see that blue LED just came up. I'm gonna hit the reset switch. This will upload the new firmware. You can see the green LED flashing. I'm gonna let that run for a while, and then we're going to go into Pronterface. And once it has restarted successfully, I'm gonna connect it to the printer, and I want to start with a fresh of fresh serial communication ports that you don't see any initial errors. So now I'm going to connect to the actual printer. Printer is now online, printer is connected. I'm going to send the command, let's say T0. Wait, hold up. I should have disabled those notifications. Let's wait a second. T0, yeah. And T0 is the tool change command. So now my idler should move for a long time. So I'm going to send T0. T0 has been sent. Is anything happening though? I don't see much for now. Let's check. Okay, so T0. Oh yeah, that's most likely because it's already considering that we are on T0. Let's send T1 maybe. T1 could work a bit better. Okay, so T1 will send that. It's actually kind of laggy. T1 invalid extruder. Oh yeah, that, you know what that was what is? That's actually because I haven't specified in my configuration file that we have a multiple extruder printer. I'm gonna need 3 extruders. I'm gonna have to rebuild that. Build it for Control Shift B. Build it for the Big Tree Tech SKR Pro. Wait, when I'm doing that, I'm gonna define single nozzle as well. I don't think I need to because that's would. Yeah, I think we're good. We don't need to uncommand a single nozzle for now. Ouch, a lot of errors. Temperature one is required with 2 or more hot ends. Okay, so I need a temp sensor for each hot end. Oh no, I'm good. And that's why I actually, in my old code, I actually defined a single nozzle because that means I don't need multiple temp sensors. So now the build should run perfectly. I'm going to get the SD card back out of the board. And we should be good. Got the SD card. I will simply delete what's on that. Even if it's a cursor file, it shouldn't be used by the board. Just to have a clean SD card. I'm going to wait for the compilation to finish, and once that's done, I will actually open the and put the new firmware onto the board. Okay, so now that we have that, I will go into Big Tree SKR Pro, revealing File Explorer, and then our File Explorer. Where is it? Yeah, right here. Okay, Big Tree SKR Pro, firmware bin inside the SD card. I will take the SD card now and plug it into my main board. Hit reset. Now the new code will upload. You see the little LED blinking right here, and I will go back to prompt face where I will send a new command. Well, same command but just new firmware. I will reset. Yes. Disconnect. Connect. Can I clear? Is there a clear function on that? Well, I know one, which is simply restarting it, but I should check for a clear. So now it's connected. I will send T1, and it's sending T1 active extruder 1 was the eco. Let's see. So now supposedly the extruder is not moving, so it should be good. But let's say. Okay, so if it had run my MMU code, it would have gone on idler, and then it would have said change to filament 2, which it did not do. Therefore, it's not using my tool change. Oh, I know why. Okay, that's because I'm currently. Oh my god, that was not smart. Okay, so I need to find the tool change function, which is somewhere. Where is it again? Tool chain right here. And here I need to well, first include the our multi-mutual upgrade clone, we'll say. Okay, so now that we have included that, we need to go to tool change, and well, this one is for void tool change, yes. So now another elif. And now that should work. I'm just gonna check on this one. So this one is for, let's see, tool change, flow and swap. Yeah, if you have multiple, wait. Yeah, so see if you have more than one extruder. Okay, so that's fine. Now the code should run fine. I'm gonna build it. Build for the Scarab Pro. Get my SD card and do all of that again. Let's see, it's working for now. Okay, yes, let's go. Now we got everything we need. I'm going to re-upload for the 100th time the code to the board. I'm gonna hit reset, and it's currently uploading the firmware. We are gonna go back into prompt phase. We're gonna relaunch it so that I have a clean serial interface to show you exactly what happens. I'm gonna connect the printer, and then we're gonna send T1 and printer halted, kill was cold. So that means that the one of the switch and was cold. So if kill was cold, oh yeah, that means that the move didn't succeed. But that means that it does that instantly. Okay, yeah. Well, let's do some debugging right here. npm-MMU. And we will serial echo pair C control V. If Control Shift build, tag, get the SD card once again. Go back to the actual build, the new firmware.bin. We'll copy it, we'll paste it right here. Now that we have the new firmware let's get it onto the board and hope that this time it works. I reset the board. I will restart prompt phase because also we just killed the printer, so the software may not like that. I shouldn't have connected it right now while it was rebooting. Cannot connect to COM1. It's not connected to COM1, it's connected to COM3, and that's why it's not working. Now online. T1. And okay, so it just received if printer dies right after, it means the endstop didn't validate the homing. So I'm going to try something that may be helpful. So that will help us tell if, as you can see, I have my screwdriver. When I turn it a bit, it touches the two and it shorts the end stop. So if T1 doesn't return that the printer was killed, I have to reset the printer though. Prompt face not responding. That's fun. I'll wait. So basically what I'm going to do is I'm going to test if the printer the end stop test works with any end stop of if you need to trigger the end stop of the specific extruder you're moving. Okay. Prompt face seems to be dead. I'm gonna kill it. I'm gonna reset the printer. Close the program. Wait. What happened? Okay. I'm just gonna restart it just to be sure as well. Let's see. Connect. It's connected. We'll send T1 while shorting the X and stop. So let's see what that does. So it's still called the kill. So that means that we have to work a little bit more on that. Actually that was pretty much what I expected, but that at least means that the code is working properly. Let's see. So that little end stop validate homing move. It's okay. So how does it work? If trigger state. Okay. So okay. Now I get it. So in that validate homing move, it just it's basically that you have to tell that it was hit on purpose. Hitting on purpose means homing. Now I have not said anywhere that I was homing, so I need to find which function to call in order to get that hit on purpose to be right. So let's see, end stops. End stop.cpp and the hit on purpose. Hit on purpose. There's only one. And hit on purpose is based on the hit state. Hit state is one function, so I'll see where hit state varies. So we have element calls. Okay, so that's basically part of the event handler. So we have the previous hit state. So if hit state, previous state. So there needs to be change in hit state. So it cannot be originally in that. So the thing I did with shorting the x-axis, that couldn't have worked. And if the new date, then it updates the hit state. If hit state says truth, I mean, I guess if it has clicked, debugging and stop head test and x xy. Okay. So I think I have to go back and see what they tell the end stops, that it doesn't just goes crazy and stops everything. Oh, that may be it. They call planner synchronize. I'm almost sure they call planner synchronize in between the move and the end. That's what I'll check right now. So end stops enable true. That needs to be on. That I have to do that. Otherwise, like, we are fucked. So MMU. So first thing is enable the end stops. Logic. Let's go. Then check if you have to home. Nothing about end stops. Then it calls the home axis. Blah blah blah. Home axis. Sync plane position. And the end for delta printers. Dual X carriage. Not our problem. End stop not homing. Okay. So that means that end stops are good. So once I finish my homing move, I have to put that back to what it was on originally. So at the end here, we've supposedly done our homing, and boom, end stop not homing. Let's see. Why do we have that tab right here? For absolutely no reason. Okay, I'll put everything back to what it should be, because it doesn't make sense to have it right here. Okay, so end stop not homing, so that would make a lot of sense. Then it clears the end stop state for SPI, but I don't have any SPI end stops, so that's fine. Restore leveling, that's not our problem. Restore feed rate and scaling. Do we touch any of that? I don't believe so. I mean, I can add it, but we'll see. Report current position, what does that do? Logical current position according to the most recent G-code command. Okay. I mean, we may add it, and then we're done. So now we have successfully enabled the end stop, so that should be positive as well. Let's see. Let's go in home axis and see if there's anything we just missed and that we absolutely need for it to work. So can home, we don't care about that. That's simply security. Debugging. The home dir has probably nothing to do with. Let's see, what does that do? Return the home direction, so it asks for the home direction, and that's yeah, so we don't need that as well. And then it synchronizes, so it waits for the move to finish, and that's what we need. Let's go. So we send the move, we wait for the move to finish, we update the position, we check if end stops have been triggered. If they have been triggered, we good. Let's build that. I mean, at that point, I really hope that works, because I still won't have time to edit it tonight. Well, I don't know. Maybe I will leave myself another weekend before posting anything. I don't. We'll see. I just hope that works, because I mean, I spent quite a bit of time on that, basically the entire day. T1. Fingers crossed. Sending T1, we don't get any move, we get processing. That makes more sense now. Just the move is actually not happening, so what could it be? Bet it's gonna take. Oh, I know why. Guys, I'm literally restarted. Check what is missing on that board. I literally didn't put any drivers. Oh my god, I'm not retarded, but almost. Okay, I'm gonna get some drivers and I'll be right back. Okay, so I got that little driver. Okay, now the printer is in. I'll just restart. What I did is just I simply disconnected that little thing. As I explained before, this is the equivalent to power switch on your computer. Now it has turned on. Now we can disconnect and reconnect. Printer is now online. We are gonna send T1. Guys, it's moving. We got this. It's moving. Now I'm gonna hit an end stop. Okay, and if that works, we're good. I don't have my screwdriver. Okay, it's right here. I'm gonna hit the X end stop. Okay, so we still have some work to do because the triggering the end stop is not enough. So what would stop the printer actually? That movie is gonna go on forever actually. So I'm just gonna kill the printer at that point. Stop, please. Okay, so now we got movement. That's a really good point. I just need to find inside those. So it actually moves. So theoretically, that would be moving towards the end stop, but it does not trigger the end stop right now. So I need to edit the end stop logic. I just reset it. The new firmware will be here. I just also realized that with this current solution, if during homing the idler is at the home position, it will absolutely break the x-axis homing, but I can fix that later. For now, I'm just trying to make this work, okay? So, it uploaded correctly. I'm gonna close that. So now I've connected printer. I'm gonna send T1. It's sent T1. The motor is turning. I'm gonna short the X max, and it should do something. Well, that's not what I expected. So let's go back to the drawing board. Oh my god. Oh wait, maybe I know what it was. I think I know. Let's see. Stop that, please. Yes. Now, okay. I have to check if the end stop triggered. End stop triggered. Quick stop. What is that called? Abort current block true. Okay, so it aborts the block. It shouldn't care about the axis that's currently triggered. So what do? I'm gonna echo, serial echo at that point, just to check that I'm doing things correctly, because I don't know if it's working correctly. So serial echo ln pair. and I will say and stop trigger. Oh my god. Yeah, fine. And stop trigger. Okay, Control Shift build. Build that. Let's see if it actually calls that, because I need it to kind of work. Let's just check how am I in terms of this space. I've been recording for quite a bit of time. It's fine. Success in the build. I haven't changed anything, so that's pretty normal. Connect printers online. T1. Send T1. T1 is sent. The thing is just moving. Now we hit that. So we didn't get any endstop trigger, so that means that the endstop is not being triggered. So that makes quite a bit of sense. I'm gonna have to fix that. Okay. So front face, disconnect, connect the printer, printer T1 send T1. Okay. Oh, at least I'm happy for that, even if it's not much and it just fucking crash front face. But this works. Let's go. Perfect. Nice. You love to see it. That means it does not recognize that axis is moving, right? So I'm gonna have to do the little thing I said that I said I was gonna do, right? So process end stop. That axis they said process end stop then min x max. Hold up. If it was that all along, I'm pretty sure. I'm gonna do min for now. That would be a short test of it. And that would definitely work. If I was right. So now I'm using xmin, which is something that we use normally, so I cannot stay with that. But I just want to check if it's because my max end stop is not defined. That's what I want to check right now. So I'm going to do it. And if it does not work, I have quite a few problems. If it does work, I know exactly what to do and we are good. Except if that SD card reader dies on me, but... Okay, firmware.bin. Go into that little removable disk. And here you go. Uploading. Front face. Disconnect. Connect. T1. Send T1. Printer is not online. Well, it should be now. Yes, it works. Let's go. I'm gonna short xmin and we'll see what it does. Hold up. Stop. Let's go. That worked perfectly. Alexa, fucking stop. Okay. That worked so well. That we are good at that point. Right here. Okay, so here, if printer dies right now, it means endstop invalid home. printer did not die. Idler homes and idler position value 0, 0. So now we just homed and the value is 0. So we have the correct value right now. And then change film to. That's enough for me. For today, that's enough. I'm going to do all the editing tonight. And I'm going to fix the problem we have with basically having the right end stop stopping this. Which shouldn't be that hard, but I'm going to work on that next time. So, let's go, yeah. Okay. I'm rolling on top of like academic papers, which is not ideal. I mean, when it's the shitty Java assignment you have to do, it's not that bad actually. Okay, so right now my homing works perfectly. That's really really nice. Like, it's kind of dumb to say, but I spent 2 months going at it the hard way, and right now it's just working. That's so cool. Yeah, let's do that again. Okay, send. Well, it's not doing anything because right now it understands that it's at the correct position. So I'm going to send T2. And T2 is just going to... And no, that's because it's homed. Right now it knows that it's home. It knows it doesn't need to home anymore. So I need to reset the board in order for it to work. So I'm going to send T2 and now it's going to work. Even T1 should work. Anything should work. I'm going to send T1. Send T1. What? Oh no, I didn't send T1. That's fine. Okay, send T1. Disconnected. Disconnect. Connect. T1. Okay, now it's sent T1. Oh, my was off. Okay, no, it just has a delay. Okay, so now it's turning. You can see it's turning. I'm gonna use my screwdriver to short the X min pin right here, and you can see that the stepper motor will stop instantly. Now I clicked it and it stopped. And basically, let's say that in real life, what would that be? That would be, so the speed on that is way too high. I'm just going to reduce the feed rate so that the homing is more like accurate in real life. But what that would mean is it starts turning towards the end stop. It turns. It hits the end stop, which won't be X min, of course, because we need that. It will be a different one. Then it stops everything. It tells, hey, this is my new homing position. And I don't have to redefine a new axis. So that's really good. That's literally better than anything I could have hoped. So we're good. Honestly, that was one of the biggest like obstacle I had to pass, and that literally like I was stuck for 2 months doing this the hard way, and I just did it in a single day. So that's really cool. So now I honestly I think even if I'm at uni, I still want to work on that. So probably less than during this summer, but I hope that I will be able to work on that at least a day every like 3 weeks or something like that. But man, that's so cool. I'm really happy right now. You can probably tell. Basically, I've been filming the entire day. I was like, I don't care what comes out of it, and I was like, yeah, 7 p.m. is my deadline to make this work, because otherwise I won't have any time to edit, and I need to sleep, and I also need to work tomorrow because I have like assignments for school, so for university, and man, it works at 6:58. That's I'm just happy. If you think that this is an interesting project and would like to follow what I do, make sure to subscribe. Also, turn on notifications, even if you're already subscribed, turn them on. If you have already turned them on, great. And if you're new and you just subscribe, turn them on as well. Because since I post like very rarely, there's kind of a low chance you will get notified and it will actually pop up in your feed. So, man, I'm so happy. I think that's it. That's the end of the video. I really hope you liked it. It was actually really fun making that little... I have X amount of hours to do that. If I don't do it, well, you see it simply not working, but it actually worked in the end. And yeah, that's great. So bye and see you in the next video.